welcome to the RAS session. And I have run this session several times at almost every connector, and because I think it's quite important, and because without RAS, the server just be the toy in your lab, right? And it cannot be a enterprise, really cannot be used in the enterprise area. So in this session, I will give you the most important things is the final part, data and plan. But before that, I will give you a brief introduction of architecture and all the components like RAS extension, APEI, SDEI, all kind of this component, and give you a prototype overview, which is implement the firmware first error handling. So let's do it. So brief introduction, and so this is the overview of all the component. It looked like a little bit complicated. Yes, it required all kind of component from the hardware to the application layer. So all the detail, I will introduce all the detail here. And first of all, hardware support for RAS. Yes, we need ARMv8, maybe v8.2 to v8.4. And also we need gig v3 or v4. But most importantly, we need RAS extension, which give us a new instruction and some register specific for RAS implementation, and also give you some function to deal with the corrected data points, something like this. So so what is a RAS extension? I think this picture can give you a big picture of that. ESP instruction just want to help you to locate the error. Where is the error, right? You can set up, it's a barrier. So you can just like the write barrier and read barrier, you just need to set up one barrier, two barrier list. And if any error happen between these two barriers, okay, the last one will trigger the interrupter. So if any error happen there, will not let the interrupter trigger after the barrier. So you can locate it, the error between these two instructions. They can help you to locate it. Okay, and then the RAS extension register can help you to control the interrupter, because every error will trigger the exception or interrupter. So this register can help you to control the interrupter and also provide the error information. So the whole register I think it's just to do two things: once provide info and control. And so why this thing's important? Because once the error happen, that means maybe software won't work, or maybe at least something in the memory doesn't work well. So maybe it cannot really help you to collect enough information from hardware. So the best way to do is to let hardware to collect the information for yourself, not really rely on the software. So that's a reason why we need to use a RAS extension. But it also provides standardized interface between the hardware and software. So if you want to learn more about RAS extension, there are two documents you need to download. One is RAS specification document. Another is architecture reference manual. These two documents can help you to really understand the RAS extension hardware. So after talking about hardware, we can talk about firmware support for RAS. Before the real things like APEI or something, I think we need to talking about the fundamental framework or fundamental function we need to use in firmware first mechanism. Because firmware, in the firmware first approach, the firmware will just work between the hardware and the OS. So how to transfer all the information? So we need to use the this SPN and security partition. This kind of mechanism already being specified by ARM engineer. So this mechanism can separate to two different parts. One is secure partition manager, which is execute in EL3, and which is BL31 in untrusted firmware. Another part is MM security partition, which we have implemented in EDK2 standalone MM. And so this part will be complied in EDK2. So okay, it running on secure EL0. So these two parts will work together. So you will see the whole picture after this. So if you want to learn more about this, you can download this ARM SPA documentation. You can this slide provide all the information. You can just download it. And then we can talking about APEI. So every time we talk about RAS, we will talk about how to deal with that by this ACPI table. So APEI include 4 different tables. That's these 4 different tables, and also how to describe the error. So we also need a info format which defined in UEFI specification. So these 4 tables, I have drawn a very detailed map, very detailed diagram at the end of this slide. You can download this slide and check these 4 different tables. But the only thing I think I need to mention is the function of these 4 different tables. One is BERT, is for once you have a very critical error, this table will tell kernel how to back up and how to find the very critical error information in the next boot. Because it's critical, so the OS has crashed down, and you can get the information in the next boot. And hash table is collect the error information in a runtime. And if you want to test the mechanism of hash and maybe BERT, you can get a help from EINJ list table. And then if you want to store all the error information to persistent storage, you need a ERST table. So these 2 documentation, ACPI and UEFI documentation, will give you all the information about this table and the CPER error format. But there's another table for ARMv8 RAS extension. You can just Google this because I also Google this and download it. And this documentation gives you an idea how to deal with RAS by kernel first mechanism. So just now we're just talking about the firmware first, but if you really want to do the kernel first, we need a way to describe the RAS extension error source. So AEST table will help you to describe this error source. But how to integrate this table to the ACPI, we have 2 approaches. One is on errors. One is put this table as a standalone table, just like hash table, like BART table, just a standalone table. Or maybe we can integrate this table into hash, like GHESV2 table. So one of the company has tried to implement this table in both of these ways. So we call it call first, because we will let customer to try which one will be better for you guys. And okay, if you think the standalone is okay, or maybe integrate into the hash table will be okay, we will try to make this approach into the specification. Then, okay, if you got information from any error source, how to describe the error in the CPER. So we also need a ARMv8 RAS extension session, this definition, this format to describe the error. So this documentation help us to do the firmware first mechanism. The last part is, actually I haven't really touched it, this mechanism between OS and firmware. So let OS can decide which interrupt it want to block. If some error always bug you, so kernel can really turn it off. You just block it. So by this mechanism, kernel can really control the interrupter and control the RAS extension. So I will show you some prototypes. So I already described all the components we will use in firmware in RAS area, in RAS function. So let's put all the things together and list the firmware first error handling overview. It's more complicated than the first picture, yes, but we can separate this picture to two different time slot. One is in the boot time, because why we're doing this in the boot time? Why we try to make the firmware to generate the to generate hash table, or maybe more specifically generate GHESV2 table. Why we want to do this? Because in the firmware first mechanism, firmware will be stand between the OS and the hardware. So only firmware know how to let OS to understand the error source, and only the firmware know how to deal with the hardware. So in the boot time, during the boot time, for now, the mechanism we are using is use EDK2 to carry the GHESV2 information through the BL31, and BL31 will carry this information to BL32, and BL32 put all the information to the non-secure memory, and the and UEFI EDK2 will transfer all information and make a new hash table dynamically. So that's the boot time. And in the runtime, once anything bad happen, any error happen, RAS extension will trigger the interrupter directly to BL31, and the very low level is EL3. So this software actually is untrusted firmware. In this software, will let the standalone NN, which running in security EL0, to collect all the information and wrap it as a CPER error block, and put all the things into a non-secure memory, and then use this SDEI dispatcher to trigger one of the handler which already been registered in the boot time, to gather information and transfer back to the application layer. So let's all process. I know it's kind of a little complicated, but I have a very detailed information in this slide. At the end of this slide, you can just check it down. So okay, that's the most important part. What is data and the plans? Actually, we already made this mechanism, this kind of mechanism, half years ago. But right now, half years ago, I'm using QEMU, but not SBSA QEMU. And QEMU is not really follow the most important ARM spec ARM server spec called SBSA. So thanks to Hongbo and Redek, they are implement the SBSA QEMU and upstream it. So right now in the QEMU, you can just use the mainline QEMU to recompile it. You can have the SBSA QEMU running on your machine. So let's a new machine type rarely follow the SBSA spec. And in the firmware side, part of the SBSA QEMU support has been partly upstream. No, so the rest of them has been post. So the information I just got today is the review has nearly finished. So all the patch for this SBSA QEMU support will be upstream very soon. And the standalone NN support for on SBSA QEMU patch, I'm just debugging it because if you want to include SBSA, if you want to include a standalone NN in your firmware, in your FIP, it will be very large and 2 megabytes. So normally, BL1, BL31, BL2, BL33, just BL31, just several K byte. But right now, if you add the standalone NN, it will become very large. So I met some size problem when I testing it. So we are trying to figure it out and fix it. Okay. Except that, we also need the EDK2 and EDK2 platform support. SBS standalone NN support patch set has been upstream, I guess, months ago, and this support for SBSA QEMU patch is under debugging because I made a problem on trusted firmware. So this debug has been delayed, but it already run on QEMU half years ago. Right now, we are just porting and then just retesting. And APEI protocol and CPRLib patch set are under debugging also with the standalone NN. So that's all the status, what we are doing, all the status. And what we are trying to, what is the next step of our work? First of all, of course, go on upstream on trusted firmware patch set. Our target is v2.2, and we also expect if we can have a real hardware to test. So if anyone has a ARMv8.2 hardware, let's include RAS extension. That would be awesome. Maybe we can have a try to test it after upstream the SBSA QEMU support. So from firmware, we'll also improve and upstream ACPI protocol and CPRLib code. My target is at the end of this year, maybe we can upstream the framework, the very basic framework, and then we can try to make it more, try to upstream more function. Also, before next connect, we will try to enable, we will try to make the EINJ prototype, which can help you to test and debug your hash table mechanism and BAT table mechanism. And if we still have time, we will try to prototype the solution of BAT. So that's some sort of EINJ mechanism, and we haven't really tried it out. Haven't really write a source code. So let's just a thought. I like to share with you. So thank you very much. That's all about the status and plan. Thank you all the people who working on this project, especially to Hongbo, who has who tried his very best to push this SBSA QEMU upstream and work very hard on that. Thank you very much. So any question? Yeah.
It was, I think, it was on your first slide. You said, yeah, about the new instructions that allow you to locate the error. You said the error synchronization barrier. No, I think just before that one. Yeah, yeah. You had another one in between, or maybe just before. Anyway, yeah. So just I wanted to clarify. It allows you to locate where the error occurred within your code, right? Not geographically in the system. Is it correct?
Yeah, yeah. Where is the
in a code section?
Yeah, in the instruction.
Okay.
Each instruction may cause the error.
Thank you.
Yeah. Thank you. Any question? Okay, thank you very much.